Today's lesson is 2.1, Modeling with Expressions. And your essential question is, how do you interpret algebraic expressions in terms of their context? So we're going to look at some definitions. Your first definition. And remember, when we do a lesson like this, I would like you to have notes on it, but I would really prefer you not take notes right now. Rather, you just pay attention and participate on the interactive slides, and then I'll post a video of our lesson to our Week at a Glance later today. It usually takes about 30 minutes for it to process all the way, and then I'll get it added to YouTube and put the link on there for you in our Week at a Glance. Then you could go back and you could rewatch it and just go through the video and pause it and get the key information out that you need. So vocabulary, we have an expression, which is a mathematical phrase that contains operations, numbers, and or variables. Yes, you can use Google Docs. That's a good question. So you can absolutely pause the video and do a screenshot of what you like and make your own notes that way. Okay, you do notes the way that's going to help you learn best.
We could write them down.
You can write them down. Google Docs.
Okay.
You can get the consumable textbook and just make notes in there, because we do go along with it. Not everything is from that, but you can always add to the pages we're in. So like right now we're in lesson 2.1, which is from the textbook, and some of the stuff is in there. Some of it I've added that you wouldn't find in the textbook. But there's two types of expressions. So you can have a numerical expression, which is only numbers, or you can have an algebraic expression, which is a combination of numbers and at least one variable. Remember, variables are the letter that represent an unknown amount. And so terms in an expression are the pieces that are being added together. So like if you had 3x plus 5, that would be two terms. 3x is a term, 5 is a term. And coefficient is the numerical factor of a variable term. So if you had 3x, the number part of that term, the 3, is the coefficient. And our last 7 notes, we were talking about equations. Okay, and an equation is a mathematical sentence where you have two expressions that are set equal to each other. You have the left-hand side and the right-hand side. So those are both expressions. And today we're just looking at the expressions, not necessarily an equation right here. All right, so this is actually from the textbook, Modeling Expressions in Context. This is a table that shows words and phrases associated with the 4 basic arithmetic operations: addition, subtraction, multiplication, division. These are key words that show up in word problems or story problems that are going to help you translate real-world situations into algebraic expressions, so that way we can do calculations and figure out unknowns, figure out our value of our variable, figure out whatever it is the question is asking us to do. So some key words that mean addition: sum of, added to, plus, more than, increased by, total, altogether, and. Right, you see those in a story problem. That's telling you that you're going to have addition. And then they give you some examples there. A number increased by 2. The sum of n and 2. N plus 2. They all mean the same thing, where n is the unknown number. For subtraction, you have less than, minus, subtracted from, the difference of, take away, taken from, reduced by. And so with subtraction, we have some examples too. The difference of a number and 2. 2 less than a number, and minus 2. Those are all examples that mean the same thing. With subtraction, you have to be careful because the order is very important. So I can't switch around the n and the 2 because I would get a different value when I do that. Addition, you have that commutability where you can change the n plus 2, and if you instead switched it to 2 plus n, you would still get the same value. But with subtraction, it doesn't work. Make sure you stay on
Mom,
mute,
did
guys.
I hear what Double said? He just said booty cheeks.
Madison.
Oh, I'm sorry.
So the difference of a number and two, make sure you pay attention to the order. When you see less than, that means that we're actually taking the two things that we're comparing and putting in the opposite order. So 2 less than a number means n minus 2. For multiplication, you have keywords like times, multiplied by, the product of, percent of, and examples of that. The product of 6/10 and a number, 60% of a number. So 6/10 and 60%, those are the same numerical value. So if you're working with a percentage, you can think of it as per 100%. So 60% becomes 60 over 100, and that's the same as 60 hundredths or 6/10. And so also of a number means to multiply by that number, the variable n. And then the last one here, division, you can have divided by, division of, quotient of, divided into, or ratio of. Those all mean division. And division is one of those ones like subtraction where the order is really important. The quotient of a number in 5 means a number divided by 5. So I have to put n, the division sign, and then 5. Or n in the numerator, the fraction bar, and then 5. I wouldn't be able to switch their order because I would get something different. Okay, so here's one that you're going to get to participate in. So you'll go to your Pear Deck tab, and we have an example. I'm first going to explain the example on the left-hand side to you, and then you're going to give me some information to help me fill out the one on the right-hand side. So example A is already done. It says the price of an item plus 6% sales tax. Price of an item plus means addition, 6% sales tax. So they've taken the phrase and they've turned it into, they've changed it into, we know what operation we have now, we're adding. And so when you don't know the value of something, what number it is, that's where you use a variable. So the price of an item is going to become a variable. In this case, they're using P. And then 6% sales tax, just like on the last slide, 6%, if I translate that into a number, it's actually 0.06. It's 6/100 because 6% means 6 per 100. 6 over 100 or 6/100. And then the tax is of the thing we're talking about, P. They're being multiplied together. So our expression then becomes P plus 0.06 times P, or because those are like terms, I can add the two terms together. And when you don't see a coefficient in front of a variable, there's an invisible one. So it's actually 1P plus 6/100 P, or 1 and 6/100 P. So now we're going to do the B example. The price of a car plus 8 5/10% sales tax. Sales tax is on the price of the car, just like the sales tax was on the price of an item in example A. So that plus sign means we're adding. So we got to figure out what is it that we're adding together. I want you to type for me an expression that would represent the price of a car as a variable plus, how would I show 8 5/10 sales tax on the price of a car? What would that look like? A lot of you are already putting P as the first variable. Fantastic. Okay. P is a good choice because we're talking about price. It helps us to kind of identify what it is we're talking about. It's not the only choice. You can use any variable you want. You can use X, you use Y, you can use C. I see a T. Okay, the variable is not important. It's just that you use one and be consistent with your variable in your expression. And then you have to figure out, how do you take 8 5/10%? How do you change that into a decimal that you can do math with? Okay, it's not just 8.5. We have to change it because Like on the example on the left, we had 6. We had to change 6. We're actually moving the decimal point 2 places to the left because we are essentially dividing by 100. We're changing it into a decimal. So you have to move your decimal point 2 places to the left. And you also need not only just the number there, but if you use the example that's right next to it, notice they're multiplying that decimal with the variable that they chose. Good, Malachi. Nice job. Good job, Mauricio. Good job, Ruben. And let me go ahead and share some responses with you, because so here, this is really close, except we're forgetting something right here. This one here, they use the variable m. So m is the price of the car, and then this is the sales tax. This is the 8 5/10% as a decimal is 85 thousandths, 0.085 times the same variable they chose. Okay, so you're gonna make sure you're using the same variable. Right here, they chose to use p as the variable, and then they used it again here. When you are writing out expressions, you do want to keep your variables in the same case. So if you're going to use lowercase, keep them both lowercase. Right here, this works perfect. All right, so don't stress about adjusting your answer too much. I'm going to go ahead and move forward. Okay, so we have, and I'm using p as my variable. It's not necessary, but that is what's being used here in this example on our lesson. So the algebraic expression is p plus 0.085, 85 thousandths times p of p. I'm almost done. There is actually one more thing to do. Because just like I had to simplify, for example, A, we are going to simplify, for example, B. So I would like you to please simplify that expression. We have 2 terms being added together. P plus 85 thousandths P. They both have a P in them. They are like terms. You can combine like terms. You add their coefficients. One of the coefficients is shown to you. It's 0.085. The other coefficient is hidden, but it's there. It's an invisible what? Good job, Ashley. Good job, Malachi. Good job, Ruben. I like that Malachi stuck with his variable. Did you pick M for Malachi?
Yes, ma'am.
Nice. Okay, so I have about half of you that have responded so far. I do want to give you a chance to respond. And don't be afraid to respond and put the wrong thing, because If you're just not answering, I don't really know how to help you with like a misconception. We are going to add together. So let's just say that first term in our algebraic expression, the term p, it has an invisible 1 in front of it. When your coefficient is 1, you don't write it typically. It's not wrong to write it, but you just don't typically see it. It's implied that the coefficient is 1 if you do not see a coefficient there besides 1. So what you're doing is you're adding 1p plus 85 thousandths p. And then what does that simplify to? About 20 more seconds. Your answer should just be, what you're typing right now should just be one term. Because if you have two like terms and you combine them, you just have one like term. Okay, so what you should have gotten is 1 and 85 thousandths p. All right, because that invisible 1 in front of the p, your first term, you have to add those coefficients. 1 plus 0.085. So when you add a decimal and a whole number, you always have to think about having the values that you're adding in the correct places. So if I'm adding a 1, which is a whole number, that's going to go in front of the decimal. So this is what you end up with. This is the correct answer here.